Alright, today we are going to talk about chords in circles. What the heck?
I thought it was some kid's thing.
I thought it was Instagram sending me stuff I don't want. Okay, anyways, chords. So we've already gone through the different parts of a circle earlier, so we won't go too much through this, but we do want to make sure we understand what a chord is. So a chord is a segment, that's the first thing, so it's a segment in a circle that, or whose, we should just say whose endpoints are on the circle. So a chord could be a diameter, but it does not have to be. So this is a chord. Okay? This is not a chord. In fact, this is a radius, right? And here is a chord right here. And there are lots of chords in a circle. Hold on. Chord. Okay, chord. It has to go from end to end. Yes, Caitlin?
What is the difference between a chord and a tangent?
The tangent touches the... Okay, so what were some properties of tangents, first of all? It touches the circle in one place. So that would be also... so a chord can't be a tangent because it only because a chord touches it, has to touch it in two spots.
So what about a secant?
Okay, why is it not a secant? Now a secant could include a chord. Okay, but a secant is going to go through the circle. Okay, a chord is inside the circle. Right, so if I extend one of these, okay, now I have two secants. All right. So that is what a chord is, but we want to know some properties of chords. Yes, Justin?
What, you remember on the circle that you just had up there? What if you completed the radius to form the diameter? Would that be a chord as well?
Yes, a diameter is a chord.
Okay.
Okay? Alright, so let's say I have a chord right here. And let's say this is a radius. Okay, what appears to be true right here? Well, it's not true right here, the thing that I'm going for. Okay, but if I draw this one, what appears to be true about that chord in radius?
Perpendicular.
They're perpendicular. Okay, so that is going to be one of our theorems right here. So if a chord is bisected by a radius, then the chord is perpendicular to the radius. Okay, and the converse of that is actually also true. If a chord is perpendicular to a radius, then the radius bisects the chord. Alright, so we have both of these properties to be true. So if this were 6 and this is x, what is x?
6.
Yeah, x would equal 6. Okay? And suppose I draw another one. Say I have another chord right here. Here's another chord. And I'll draw this radius. And I'll tell you that these are perpendicular. So if they're perpendicular, what do I know is true about the chord?
It's bisected.
It's bisected. So suppose this whole thing right here were 25. Then what is x and y?
12.5.
Yeah, 12.5. 25 divided by 2, or 12.5. It would divide it into 2 equal parts because that's what bisected means. Okay, so you could say a chord is bisected by a radius if and only if they are perpendicular. That would be a shorter way to write those two things. So we could write that a chord is bisected by a radius if and only if the chord is perpendicular to the radius. So that summarizes what we just talked about right there. Now we have one more thing that will appear to be true. So let's see if we can get that. If I have a chord right here, and let's say I have a chord right here, and then I have a radius drawn to both of those. Now, every radius is the same length, so that is going to be the case, certainly. But what if I tell you this little piece right here and this little piece right here, what if those are the same? Suppose those are both 5. Okay? Let's say those were both 5. And let's say the whole radius was 6. So let's say I complete this circle, then this is 6, and this is 6. And then this is a right triangle, because those are perpendicular. I have hypotenuse and a leg, right, for that right triangle, which means this and this are the same. You with me?
Yes.
So by HL, those two triangles are the same, and then that means by CP, CT, corresponding parts of congruent triangles, this is the same as this, which then would mean this whole thing is the same as this whole thing.
Correct.
So that means if a chord, if two chords are the same distance from the center, then their lengths are equal. Are you okay, Justin?
Yeah.
Okay. So, let's just kind of rehash that whole diagram again once more so that you see. I'll use a different color here. So what we're saying is, if this little segment here is congruent to this little segment, okay? And these are perpendicular, so we're meeting the requirements of the first thing we talked about. So these are bisected. Now this is a radius here, right? And all radii in the same circle are the same length. So if I draw this radius, and I draw this radius, okay, those would be the same. You with me so far? Now I have a right triangle. This is a hypotenuse. This is a hypotenuse. This is a leg. This is a leg. So these triangles are congruent by HL, which means all their corresponding parts are the same, which means this side is the same as this side. But these whole segments right here, this segment right here and this segment right here, both those chords have been bisected. So these would be the same. Thus making this whole length the same as this whole length. So the chords would be the same. So thus, if two chords are the same distance from the center, then their lengths are equal. So let's use that for something. Let's say I have a situation like this. I'll throw some two chords in there, and since I'm throwing them in there, I don't know if they'll actually appear to be the same length, but I mean them to be. And here's our center. And let's say I draw this. I gave you it's perpendicular, so I know it's been bisected. I'll draw this. It's perpendicular, so I know it's been bisected. Let's say this is 6, and this is 6. Let's say this right here is x. And let's say this length right here, let's give it a length of 5. Okay? So, because both of these, you see this chord and this chord, since they're the same distance from the center, I know that they are the same length, which means this is how long? 5, which means x is
2.5.
2.5. Okay? And that's actually all we need to do for today. So we are done.
Make sure to like and subscribe.
Yes, bye,
Pause yet.
It says follows under.
but.